Welcome friends. Today in this lecture, that is the lecture number 9, which is the part of our chapter number 1 DC circuit, which is the part of the basic electrical engineering. We are going to discuss in this lecture number 9, network theorems, Norton theorems. Means in this lecture we will only focus on Norton's theorem. We already discussed superposition theorem, and then we done with Thevenin theorem. Now we are going to discuss Norton theorems. Okay, this is the network theorem, means to solving a many complex network or for the higher studies in the electrical system, higher studies or higher analysis of the complex circuit in a electrical environment, we need to frequently use the Thevenin and the Norton's theorem. Okay. So, let us start with the very important theorem, that is the Norton theorem. Okay. So, same as the Thevenin theorem, how we proceed for the Thevenin theorem, in similar fashion we will discuss the Norton's theorems. So our today's topic, that is the Norton's theorem. Okay. So what is this? What is the statement of the Norton's theorem? Like Thevenin theorems. Okay. So a linear active RLC network containing more than one independent or dependent voltage and current sources can be replaced by a single short circuit current source, single short circuit current सोर्स, जिसको हम लोग ISC से रिप्रेजेंट करते हैं और IN से भी कभी कभी रिप्रेजेंट करते हैं, नॉर्टन करंट. ठीक है. सो ISC इन shunt with an equivalent impedance. अगर हम लोग सिर्फ DC सर्क्यूट DC सोर्स का बात करें तो उस टाइम में हम लोग सिर्फ R0 करेंगे एज्यूम, क्योंकि उस टाइम में सिर्फ इम्पीडेंस जो है हमारा सिर्फ रजिस्टर हो जाता है. ठीक है. सो नॉर्टन थ्योरम का ये हो गया. सो नॉर्टन थ्योरम क्या बोलता है? लीनियर एक्टिव RLC अगर नेटवर्क हो, लीनियर भी हो, एक्टिव भी हो और RLC नेटवर्क हो, कंटेनिंग मोर देन वन इंडिपेंडेंट और डिपेंडेंट वोल्टेज एंड करंट सोर्स. अगर उस सर्किट में एक या एक से अधिक इंडिपेंडेंट या डिपेंडेंट वोल्टेज या करंट सोर्स हो, तो उसको हम लोग किससे रिप्लेस करेंगे? एक सिंगल शॉर्ट सर्किट करंट सोर्स से, और उसके साथ एक पैरेलल इक्विवेलेंट इम्पीडेंस हम लोग यूज करेंगे. मतलब कोई भी सर्किट हो तो उसको हम लोग कैसे रिप्रेजेंट करेंगे? एक सिंगल करंट सोर्स से और उसके साथ एक पैरेलल जेड इक्विवेलेंट लगाएंगे. ठीक है. और इसका ये हो जाएगा आपको नोड A नोड B. and this will be equal to this will be Z equivalent, and this is your ISC. So this is your nothing but your Norton's equivalent. सो दिस इज़ योर नॉर्टन इक्विवेलेंट. नॉर्टन इक्विवेलेंट क्या हो गया, एक शॉर्ट सर्किट करंट होगा और उसके साथ एक पैरेलल जेड इक्विवेलेंट, और जिसको हम लोग बोलते हैं नॉर्टन इम्पीडेंस भी बोलते हैं. ठीक है, जैसे थेवेनिन में थेवेनिन इम्पीडेंस निकालते हैं, उसी वही सेम प्रोसेस से हम लोग जेड इक्विवेलेंट निकालते हैं, कैलकुलेट करते हैं. ठीक है, सो तो नॉर्टन थ्योरम क्या हो गया, लीनियर होना चाहिए और एक्टिव होना चाहिए और आरएलसी नेटवर्क होना चाहिए जिसमें कंटेनिंग हो मोर देन वन कंटेनिंग मोर देन वन, एक से ज़्यादा इंडिपेंडेंट या डिपेंडेंट कौन सा सोर्स, वोल्टेज या करंट सोर्स, कोई भी सोर्स हो, तो उसको हम लोग रिप्लेस करेंगे किससे, एक सिंगल शॉर्ट सर्किट करंट से जिसको आईएससी बोलते हैं. उसके साथ शंट में क्या होगा, एक इक्विवेलेंट इम्पीडेंस या जेड इक्विवेलेंट होगा. ठीक है, सो द नॉर्टन इक्विवेलेंट विल बी दिस वन. सो दिस इज योर simple statement. Now where same as that one, not ये थेवेनिन में क्या था, थेवेनिन में क्या था कि आपका एक वोल्टेज सोर्स होगा, उसके साथ एक सीरीज जेड नॉट होगा ना, इस तरह से रिप्रेजेंट करते थे थेवेनिन में. लेकिन नॉर्टन में इस तरह से, तो आप बाद में मीन्स इसी लेक्चर में हम लोग आगे देखेंगे कि ये दोनों क्या होता है, डुअल होता है नेचर. मतलब अगर आपको नॉर्टन अगर पता है तो उससे हम लोग थेवेनिन भी अटेंड कर सकते हैं, क्योंकि VSC को क्या लिख सकते हैं, ISC, VOC को क्या लिख सकते हैं, ISC इंटू जेड इक्विवेलेंट, और ये क्या होगा इम्पीडेंस जेड इक्विवेलेंट. मीन्स ये इम्पीडेंस और ये इम्पीडेंस दोनों सेम ही होता है. ठीक है, देखेंगे वो. सो वेयर जेड नॉट, और जिसको हम लोग थेवेनिन इक्विवेलेंट भी बोलते हैं या नॉर्टन इक्विवेलेंट भी बोलते हैं या इक्विवेलेंट भी सिंपली बोलते हैं, इक्विवेलेंट रिप्रेजेंट इक्विवेलेंट इम्पीडेंस between the two terminals of the network when जैसे अब ये when का मतलब क्या हो गया, जैसे हम लोग थेवेनिन में लिखे थे, whenever there is a voltage source होगा तो क्या होगा, इंडिपेंडेंट अगर वोल्टेज सोर्स होगा तो उसको क्या करेंगे, शॉर्ट सर्किट करेंगे या इंटरनल रेजिस्टेंस से रिप्लेस करेंगे. ठीक है. नंबर बी, अगर यदि करंट सोर्स हो इंडिपेंडेंट तो उसको हम लोग क्या करेंगे, करंट सोर्स को ओपन सर्किट करेंगे या फिर इंटरनल रेजिस्टेंस से रिप्लेस करेंगे. अगर आपको डिपेंडेंट सोर्स हो तो उसको कुछ भी नहीं करना मतलब कि एज इट इज़ मीन्स जैसा है उसको रहने देना और उसके बाद हम लोग को सॉल्व करना. और ये ISC क्या है, ISC इज़ द सिंगल शॉर्ट सर्किट. मान लीजिए AB टर्मिनल के अक्रॉस जो कॉम्प्लेक्स सर्किट है उसमें AB के अक्रॉस आपको ये निकालना है ISC. तो क्या कर देंगे हम लोग, AB टर्मिनल को शॉर्ट सर्किट कर देंगे, और शॉर्ट सर्किट करने के बाद उसमें जो मैक्सिमम के जो भी शॉर्ट सर्किट करंट फ्लो होगा दैट विल बी योर ISC. सो दिस इज़ ऑल अबाउट योर नॉर्टन के थ्योरम थे. ठीक है, न्यूमेरिकल देखेंगे और इजीली हम लोग अंडरस्टैंड करेंगे कैसे हम लोग नॉर्टन इक्विवेलेंट कैलकुलेट करते हैं. ठीक है, और यहाँ पर कुछ पॉइंट्स है, जैसे हो गया आपको नॉर्टन इम्पीडेंस क्या होता है, इम्पीडेंस, और रेजिस्टेंस किस केस में हो जाएगा, जब आपका डीसी सर्किट हो, सब कुछ डीसी होगा तो उसमें सिर्फ रियल पार्ट ही होता है, दैट इज द ओनली रेजिस्टेंस विल बी देयर. इफ देयर इज एसी देन इम्पीडेंस कंसेप्ट विल कम इनटू पिक्चर. ओके, सो नॉर्टन इम्पीडेंस इसको हम लोग कैसे लिखते हैं, जेड एन से लिखते हैं, या फिर जेड नॉट बोलते हैं, या फिर जेड इक्विवेलेंट भी बोलते हैं. नॉर्टन इक्विवेलेंट और थेवेनिन इक्विवेलेंट दोनों क्या होता है, सेम होता है. ठीक है, नॉर्टन करंट क्या होता है, नॉर्टन करंट को ये भी बोलते हैं शॉर्ट सर्क्यूट करंट आई एन, या फिर शॉर्ट सर्क्यूट करंट, जो ऊपर में हम लोग ने फाइंड आउट किया है. ठीक है, ये हो गया पॉइंट. अब देखिए, अब बहुत ज़्यादा इंपॉर्टेंट पॉइंट है, क्या है, इट इज़ इजली सीन दैट Norton equivalent follows from the Thevenin equivalent by source conversion and also vice versa. So we can say it is easily seen that the Norton equivalent follows from the Thevenin equivalent by source conversion and also vice versa. So vice versa, obviously what we can write, Zn जो नॉर्टन इक्विवेलेंट इम्पीडेंस है दैट विल बी इक्वल टू थेवेनिन इक्विवेलेंट. सो इसका मतलब क्या हुआ कि जो हमारा थेवेनिन इक्विवेलेंट सर्किट होता था, जैसे कि ये वाला ए बी टर्मिनल हो गया, ये होता था आपको वी ओ सी, और ये हो गया आपको जेड टी एच. तो इससे ये जो है ना, सोर्स कन्वर्सन क्या होता है, अगर वोल्टेज सोर्स है उसके साथ अगर सीरीज इम्पीडेंस है तो उसको हम लोग एक करंट सोर्स और उसके साथ एक पैरेलल रेजिस्टेंस में कन्वर्ट कर सकते हैं. सो दिस कैन आल्सो बी कन्वर्टेड एज लाइक दिस वन, देयर विल बी वन, दिस इज योर वोल्टेज सोर्स. ओके, देयर विल बी वन करंट सोर्स एंड उसके साथ एक पैरेलल में एक इम्पीडेंस होगा, और इम्पीडेंस जो पैरेलल में होता है वो सेम एज दैट वन होता है. ठीक है, सो that one means this will be your ZTH, and this current source होगा, that will be magnitude will be VOC into ZTH, and this let it be, this is I, let it be I. So ये this circuit is same as your Norton equivalent. So what we can write, ISC or IN, that is the Norton equivalent, is nothing but your ZTH into VOC, or and your ZTH is nothing but your Zn, or Zn means Thevenin equivalent impedance is equal to Norton equivalent impedance. So this is your simple. Okay, so अगर आपको थेवेनिन वोल्टेज भी निकालने बोले या फिर ओपन सर्किट वोल्टेज भी बोले, तो दैट विल बी इक्वल टू सिंपल IN means Norton current into ZTH. Simple. This is simple. Actually here you did one mistake, because the current will be what? Current will be voltage VOC divided by ZTH. So there is a error here. Okay, because this I means this current is what? Simple, that is VOC divided by ZTH. Okay, so there is a mistake, VOC on, then now it's okay. Okay, so VTH will be IN into ZTH. This is simple. Now the point is that in the network, if there is a dependent source, then what we need to do, dependent source cases, it is also very important for the various examination. How to solve when dependent sources are present. Very important. When dependent sources are present, it is it is convenient to obtain ZTH in case of Thevenin or Norton. Okay, ZTH from ZTH इक्वल टू आपको क्या निकालना है, ओपन सर्किट वोल्टेज निकालना है डिवाइडेड बाय शॉर्ट सर्किट करंट। एक बार ओपन सर्किट वोल्टेज निकाल लीजिए उस टर्मिनल का, और उसको क्या कीजिए, उस टर्मिनल को शॉर्ट करके उसका करंट निकाल लीजिए और दोनों को रेशियो कर दीजिएगा, तो आपको थेवेनिन या फिर नॉर्टन इक्विवेलेंट इम्पीडेंस आपको निकल जाएगा। और कैसे निकाल सकते हैं, और बाय गिविंग इनपुट एज 1 वोल्ट। मान लीजिए आपने क्या किया, इनपुट को 1 वोल्ट दे दिया, ठीक है, 1 वोल्ट दे के सो करंट आई, लेट इट बी आई विल बी आई, मान लीजिए, और आपने इनपुट दिया 1 वोल्ट, ठीक है, कितना दिया इनपुट 1 वोल्ट दिया, और उसके कॉरस्पॉन्डिंग मान लीजिए करंट जो है ना आई करंट फ्लो हुआ, तो आर इक्विवेलेंट क्या होगा, मीन्स टोटल इक्विवेलेंट वोल्टेज डिवाइडेड बाय करंट। सो वोल्टेज इज 1 बाय आई। तो इस तरह से हम लोग ईजिली हम लोग ये रेजिस्टेंस मीन्स इम्पीडेंस जो थेवेनिन या फिर नॉर्टन इक्विवेलेंट इम्पीडेंस होगा वो ईजिली हम लोग कैलकुलेट कर सकते हैं, ठीक है। समझ में आया ना, डिपेंडेंट सोर्स के लिए, क्योंकि डिपेंडेंट सोर्स को हमको कुछ करना ही नहीं, उसको कुछ भी चेंज नहीं करना है, ठीक है। तो आप बताइए प्रैक्टिकल सर्किट में ZTH जो ऑब्टेन करते हैं वो हम लोग कैसे ऑब्टेन करते हैं, बाय ओपन सर्किट वोल्टेज एंड शॉर्ट सर्किट करंट। ये दोनों की हेल्प से हम लोग क्या निकाल लेते हैं, Z मीन्स इक्विवेलेंट थेवेनिन इक्विवेलेंट इम्पीडेंस या नॉर्टन इक्विवेलेंट इम्पीडेंस। नाउ इट्स टाइम टू go for some numericals. Okay, so question number 1 is that find Norton equivalents as seen at terminal AB के अक्रॉस जो नॉर्टन इक्विवेलेंट होगा that we need to find out. So let this be your current source. Okay, let there is a resistance and again there is a resistance like this one. Okay, and there is a one more resistance, that is load. Let the load be represented as your capital R, and there is a two terminal A and B, and this is your voltage source of 32 volt, and this is your of 20 ohm resistance, and let this be of 2 ohm resistance, and this is your 8 ohm resistance, and there is a current source of 1 ampere. So this circuit is same as the example what we solved in the previous lecture. Okay, so same circuit, but the difference is that in that circuit we found Thevenin equivalent, but in this circuit we need to find out the Norton equivalent by considering the both the Thevenin numerical example and this Norton example. We can prove that the Thevenin equivalent and the Norton equivalent is dual to each other. Means if you know the Thevenin equivalent, then we can easily convert into the Norton equivalent, and if you know the Norton equivalent, then easily we can find out the Thevenin equivalent. Okay, and vice versa, or we can simply by using the source conversion we can get each other. Okay, so in this, how to proceed for this one, we will go by step. So step 1, what is the step 1? First we need to find out the equivalent current. To find Norton's equivalent current ISC. Okay, Norton equivalent current ISC. So, to find out the Norton equivalent current, what we need to, we will redraw this circuit and then easily we can. So, for the finding out the current ISC, means what we will do, it is the means it is the load current, means through the terminal AB 1 minute. First you tell me this is your circuit. So, for this one Norton equivalent means we need to find out the Norton equivalent across this one. Okay. Norton equivalent of this one means this will be, we need to represent this as like this one. There will be one current source and there will be one impedance in parallel, and then there is your load is given as capital R, like this one we need to represent. Okay. So, capital R is this one, this is A terminal, this is B terminal. So, okay. So, to find out the ISC, what we need to do, this is the current means short circuited current, means by shorting the terminal AB. So, what we will do, we will short this terminal. So, what we will do, we will short this terminal like this one, and the current in this branch, or we can say between AB terminal, the current, that is the ISC short circuit current, that we need to find out simply. Okay. So, for this one we will redraw a circuit. Okay. So, it will be going back, okay, like this one. Okay. So, now what will be the new means modified circuit, or what we can say, we will redraw circuit like this one. This will be your current source ISC, means current source means 1 amps it is given, and there will be one resistance, and there is one more resistance like this one, and there is a resistance and one voltage source. If you have any doubt, kindly comment in the comment section. Okay. And this is your शॉर्टेड टर्मिनल. ओके, जिसको हम लोग ने सिंपली शॉर्ट किया. शॉर्ट का मतलब क्या हो गया, वी विल सिंपली कनेक्ट अ कंडक्टिंग वायर, एक कंडक्टिंग वायर के थ्रू से मीन्स कनेक्ट कर देते हैं दोनों टर्मिनल को, ए बी को. तो कंडक्टिंग वायर से जो कनेक्ट करते हैं उसमें क्या होता है कि लॉस नहीं होता है, मीन्स हम लोग ऐसा एज्यूम करते हैं उसका रेजिस्टेंस या फिर इम्पीडेंस क्या होता है, जीरो, मीन्स पूरा शॉर्टेड होता है. ठीक है. जब ये शॉर्टेड होगा तो आप बताइए, जब ये शॉर्ट सर्किट हुआ तो इसका वोल्टेज क्या होगा, वोल्टेज एट दिस टर्मिनल विल बी व्हाट, जीरो, क्योंकि शॉर्टेड में क्या हो गया, मतलब कि ये पॉइंट का वोल्टेज क्या होगा, सेम. और पोटेंशियल डिफरेंस V ऑफ SC इज़ द पोटेंशियल डिफरेंस बिटवीन दिस टू टर्मिनल, या फिर आप V ऑफ AB भी लिख सकते हो, दैट विल बी इक्वल टू जीरो इन दिस केस बिकॉज वी हैव शॉर्टेड हियर. व्हाट इज दिस, दिस इज शॉर्ट सर्क्यूटेड. ओके, यहाँ पर हम लोग क्या किए, शॉर्ट सर्किटेड किए, और सबका वो पुट कर दीजिए मैग्नीट्यूड मीन्स वैल्यू, दैट इज़ 32 वोल्ट. दिस इज़ हाउ मच, 20 ओम. दिस इज़ हाउ मच, this is 2 ohm, this is how much, this is 8 ohm, and this is 1 amps current. So, now we need to find out the ISC. Our main aim is to find out the ISC. How we will proceed for that one, we can follow any method so that we can easily find out ISC. Okay. So in this circuit we can see here that these two are the current source and there is a one parallel resistance. So, we will convert this into a voltage source conversion we will apply. So, this will be equal to one voltage source of magnitude how much, I into R, that is 8 into 1, that is 8 volt, and there will be one series resistance that will be same as the parallel, that is 8 ohm. So, this circuit can be represent again redrawn, again we will redraw this circuit. Okay, like this one. Okay. like this one, there is a one more voltage source and there is a these two terminal are nothing but the short circuited. ठीक है, okay. So this is plus minus 32 volt, this is ohm 20 ohm resistance, this is 2 ohm resistance, this is 8 ohm resistance, this is 8 volt voltage source. Okay. Now to solve this circuit, we will assume that this current is your I2 current, and let this current be, means in this branch let it be I1, and this current we already know that is ISC. Okay. So now in this, how we will solve the current? There is a simple method. Simple method is what? Tell me. Simple method, tell me. I1 is there, na? I1, I2, and this is your ISC. Okay. How to find out I2? I2. For finding out I2, what we will do? Actually, because here it is short circuit, so this terminal, voltage across this terminal will be how much? This, let it be x point and this be y point. So V of x y will be nothing but your 0. This potential will be how much? 0. Simple. Why it is 0? Or we can apply the KVL in outer loop, and then we will apply the KVL in the inner loop. So for the simplicity, we will assume not, means by looking at the circuit, your V x y will be your 0 obviously. Therefore, what we can write, I2 equal to 8 volt, because it is flowing from 8 volt to where? It is 0 volt, 8 volt to 0 volt. So 8 minus 0, your difference, divided by total resistance. Total resistance is how much? 8 plus 2, 8 plus 2 is 10. So it will be 0.8 amps. Understand now? How we retain this one? Because if there is a two source, okay, like this one connected, one it be plus minus V1, and there is a resistance, let it be R, and there is another voltage source like this one of same polarity, like plus minus, okay, let it be V2. Then what we can write? The current through this branch, that is I, that is flowing from higher to lower. So V1 minus V2 divided by total resistance. So this will be current. In the above question, our V2 will be equal to how much? It will be 0, because the terminal XY terminal across this one is a short circuit line. Because of the short circuit, the voltage across the short circuited terminal will be obviously 0. So this is like this one. Okay. So we have calculated I2. Now our task is to find I1. How we will find out I1? I1 will be same process. We will find out I1. I1 is this one, na? I1 here. So I1 will be equal to, again, 32 minus 0 divided by how much? 20. Why? Because there is a 20 ohm connected. So this will be 1.6 amps. How this happened? We will see. This is like this one. This is your 32 volt and this is your 20 ohm resistance, and this terminal, or what we can see here, this terminal and this terminal is your 0 potential, means this is connected to your 0 volt, plus minus 0 volt. Okay, 0 volt, let it be like this one. So this circuit is like this one. So what we can write? I equal to 32 minus 0 by 20. Simple. So I1 and I2 we have calculated. Now from the above diagram, from this what we can write? ISC. ISC will be equal to simple I1 plus I2, because at this node we will apply a KCL, because for the KCL at a terminal, the incoming current, sum of the incoming current equal to sum of the outgoing current. Sum of the incoming current is what? I1 plus I2, and sum of the outgoing current is only one, that is ISC. So ISC will be I1 plus I2. So therefore what we can write? ISC will be equal to I1 plus I2, and hence that will be nothing but your 0.8 plus 1.6. So, it will be 2.4 ampere. So, this is your ISC, short circuit current. Now, we will move for the second step, step number 2. Step number 2. What is the step number 2? Here we need to find out the second parameter, that is Norton equivalent impedance. So, we need to find out Norton's equivalent impedance, and in case of DC, if there is only DC circuit, DC element are there. So, in that case we will calculate resistance. So, here what will be Norton equivalent impedance we need to find out. So, how we will find out the Norton equivalent? By looking at this circuit, it is the same method as an Thevenin equivalent. इन जैसा मैंने हम लोग ने सॉल्व किया है प्रीवियस लेक्चर में जो हम लोग ने थेवेनिन इक्विवेलेंट निकाला है, कैसे निकाला था याद है आप लोग को? इट इज़ सिंपल. व्हाट वी विल डू, वी विल रिमूव दिस वन, इसको रिमूव कर देना है, ओपन सर्किट कर देना है, ठीक है. और उसके बाद ओपन सर्किट करने का मतलब क्या हो गया, कुछ इस तरह से कर देना है. ओके. और यहाँ से हम लोग को ये ZN बोलो या फिर ZTH बोलो या फिर Z और क्या है ZOC बोलो या फिर ZSC बोलो, ये सब हम लोग एक ही टर्म है. नॉर्टन इक्विवेलेंट, थेवेनिन इक्विवेलेंट, ओपन सर्किट इन केस ऑफ थेवेनिन और शॉर्ट सर्किट इन केस ऑफ नॉर्टन, ये सब इम्पीडेंस हम लोग इजीली कैलकुलेट कर सकते हैं यहाँ से लुक करने से. तो इस केस में कैसे फाइंड आउट करते हैं, जो भी आइडियल करंट सोर्स है उसको ओपन, जो भी आइडियल वोल्टेज सोर्स है उसको शॉर्ट, और जो डिपेंडेंट सोर्स है उसको रहने देते हैं. तो ये क्या हो जाएगा आपको, ये ओपन सर्किट हो जाएगा, ये इस तरह से हो जाएगा, और ये क्या हो जाएगा आपको, ये शॉर्ट हो जाएगा. तो इसको इक्विवेलेंट कैसे हो जाएगा, इसका इक्विवेलेंट क्या हो जाएगा, टेल मी. सो दिस टू विल बी योर सीरीज. सो 8 + 2 10, 10 विल बी पैरेलल टू your 20. So, 10 and 20 will be parallel. So, this will be nothing but your 20/3. So, because it is a question, so we need to clear this one. Okay. So, this will be okay. 1 minute, one more thing is there. So, we will remove this one. Okay. This is okay now. If you have any doubt, kindly comment in the comment section. Okay. So, our now task is to find out the Norton equivalent. So, for this one what we have done in a previous lecture numerical, that is in Thevenin, we proceed in the same way. And this is your nothing but your ZTH, or we can write ZN. Okay. So, this is your 20 ohm, this is your 2 ohm. What is the unit of impedance? 8 ohm. Ohm. What is the unit of impedance? Ohm. So, in this circuit this 2 is in series. So, 8 + 2 10, and this 10 is parallel with your 20 ohm resistance. Okay. So, this will be 20/3 ohm. So, step 2 is completed. Now, we will move for the third step. Step third. What is the step third? What we need to find out? We need to find out Norton equivalent. Norton equivalent. What is the Norton equivalent? Norton equivalent is this one. There is one current source like this one. Okay. And there is one parallel resistance. Okay. And this is across terminal A and B, across A and B, and this Norton is your I of N, and this is your Z equivalent, or we can write Zn. So, this is your nothing but your Thevenin Norton equivalent, because it is a final step of the Norton equivalent. As we have already calculated the values, so we will put the values. Zn or ZTH or Z equivalent is equal to 20/3 ohm, like this one, or IN, that is also known as short circuit current, which we have calculated as 2.4 ampere. So, this is your final Norton equivalent. Up to this we need to solve in an examination. So, this is your Norton equivalent. Okay. And because there is a load is also connected, so we will connect also a load across this Norton equivalent. So, this is your capital R. Okay. So, this is question 1. Okay. Now, we will proceed for the question number second question. Question number 2, it is very important question, question number 2. Okay. In this, find Thevenin equivalent. One more important thing is that from this circuit we can also find Thevenin equivalent. Thevenin, how we will find Thevenin equivalent? What will be the VOC? VOC will be IN into ZN, ZN into IN. What will be that one? 2.4 into 20 by 3. So, 0.8 into 16, it will be 16. Okay. 0.8, 8 3 ja 8 2 ja 16. So, 16 volt will be your this one, and what will be ZTH? ZTH is same as ZN. So, Thevenin equivalent will be equal to like this one voltage source and one series impedance, and this is your node. This is your 16 volt and this is your voltage source of 16 volt and Zn of 20, Zn of 20 by 3 ohm, and there is a one load is connected like this. So, this is your Thevenin equivalent. So, this is dual in nature both. From this we can find out Norton, and from Norton to Thevenin and Thevenin to Norton and vice versa. Okay. So, find the question is that find Thevenin equivalent of circuit which has one dependent. अब मान लीजिए इस क्वेश्चन में क्या है, एक डिपेंडेंट सोर्सेस है, वन डिपेंडेंट सोर्स है, ठीक है. तो आप इसमें कैलकुलेट करना है क्या प्रोसेस है. वी विल फॉलो द स्टेप बाय स्टेप एंड वी कैन इजीली गेट द सॉल्यूशन. Okay, so let the circuit be like this one, and there is one current source, and parallel में क्या है, in parallel there is a one resistance. Let this be plus minus terminal and the terminal name be A and B. Okay, and this be your V of OC, open circuit voltage, and this be 20 ohm resistance, and this is your current source of 3.5 I. Okay, and this let the current, because 3 I means this is dependent on I. So, why I? Where is I? I is the this branch current here. Here is this branch current, means 10 ohm resistance branch has the carrying the current I, capital I. So, though this 3.5 into I depends on a current I, means other branch parameter. So, this current source is what? This is current dependent current source. Okay, because it's depend on the current of the other branch, and this is your voltage source of 100 volt. This is DC circuit, everything is in DC. Okay, so to solve this question we will proceed step by step. So, step 1, what we need to find? Step 1, VTH, or what we can find? VOC. How to find VTH or VOC? So, there is a lot, there are many ways to solve a question, but in this question we will follow a different method. We will convert this current source into a voltage source. Okay, and then we will, and there will be only one loop, and then we will apply KVL. Okay, so this after source conversion, what will be the circuit? So, this will be like this one. Okay, Okay, this is your plus minus, this is your VOC, and this is your plus minus. This will be how much voltage source? This will be converted, means voltage will be how much? Voltage source, current into R, R into I. I means I is how much? Current source 3.5 I into R. R is what? How much resistance? 20. So, it will be 7 it will be 70 I. So, our current source is nothing but your 70 I. So, this is your current source, and let this is already given of 20 ohm, this is your already given as 10 ohm, and this is your 100 volt plus minus. Okay. And this is the current, that is the I. What is this I? 70 I. In the 70 I, where is I? I is this current, I is this current. So, now we will erase this one, so that we should not confused. Okay. So, this is your circuit, means what we can say, it is a means this is your simplified circuit. Now, in this circuit we are going to apply a KVL loop, we are going to apply a KVL, like this one KVL we are going to apply. Okay. KVL, or we can say mesh analysis we will do, because here everything is in voltage. Okay. So, let this loop current is current I. So, we will mark the polarity of this, like this one plus minus, and here also plus minus. So, we will apply the KVL. First, what we did? Converting the source conversion. After source conversion, we will apply the KVL. KVL in, there is a single loop, so we will apply the KVL. So, this current is in contrary minus, so we will put here minus, here it is a plus, so it will be plus of 10 into current I, here is again plus, so plus 20 of I, here it is again plus, so it is plus of 70 I, because this is your voltage source equal to 0. So, this is your KVL equation. So, from this what we can find I equal to your 1 ampere will be current, I will be your 1 ampere current. So, therefore, what we can write? V of OC is this voltage across this terminal. So, how we will write VOC? VOC is simply by looking at the circuit we can write, as there is a plus minus. So, there is a voltage drop across resistance, that will be 20 into I, plus there is a voltage source of 70 into I. So, it will be your 90 into I, and this is nothing but your 90 volt. So, we have calculated VOC by following the simple method. Okay, by simplifying the given circuit, we are able to find out the VOC, and this is nothing but your Thevenin voltage. Thevenin voltage we found out. Now, our second target will be what? If you have any doubt, can you comment in the comment section. Okay. Now, our second step will be to find out the RTH. Step 2 is to find RTH, or what we can write R naught, RTH, ZTH, Z naught, whatever you want you can find out. Okay, you can write. Now, how to find out RTH and R naught? So, what we will do this method, how to find out this one? Actually, for finding out the RTH and ZTH, we have seen in the above page that for finding the RTH, R naught, Z naught, we will simply write the formula, that is the Z TH equal to VOC by ISC. So, VOC by ISC. So, if we short circuit here, okay, what we will do? if we will simply short circuit this one and we will find the, if we are able to find out the short circuit current, then we can simply take the ratio, we will find the V ZTH. Why not we will follow the our conventional method to find out the ZTH, means by short circuiting the this ideal current voltage source, or short circuiting the ideal voltage source and this dependent current source, we will leave that one as it is. Why not? Because if you short circuit this one 100 volt, because if you short circuit this one 100 volt, then your I is the current, I will be what? I will be your 0. If your I will be 0, if this is I is 0, then that means 3.5 I, that is the current source, that will be also be 0. So, this is not our desired condition to solve a circuit for a Thevenin impedance. Okay. So, why we are not following the conventional method? Because it is obvious that R naught, or we can say RTH cannot be found. Why I am writing this statement? Because if you have, because by reading by yourself, you will be clearly understand and if you are making the note, so that will be easy for you to follow that note. Okay. Dependent source, our dependent source, that is your 100 volt as the dependent current source. That is your, how much? It is 3.5 I, as I will be 0, as short circuiting 100 volt. Okay. So, as the dependent current source also get eliminated. So, we will not follow that conventional method, we will follow the simple method, that is to find out the ZTH or the Thevenin equivalent, or Z naught. We will simply find VOC divided by ISC. VOC we already found, that is 90 volt. Now, we will proceed to find out the this one, what is this? ISC. Okay. So, how to find out ISC? Tell me. ISC, for finding out the ISC, short circuit current, we will short this terminal. Which terminal? This terminal. We will short this AB terminal. AB terminal को हम लोग क्या करेंगे? Short. ठीक है. So we are going to redraw a circuit. So this circuit will be like this one. There is a one voltage source is already there. Okay. There is a one resistance like this one, and there is a one current source is like this one, and there is a one parallel resistance like this one, and there is a terminal, AB terminal. Now, this terminal we are going to short circuit like this one, and the short circuited current will be flow from this to terminal AB. Okay. And this is your 20 ohm resistance, and this is how much? 10 ohm resistance, and the I is the current through this one, and here this is 3.5 into I. Okay. And this is your voltage source of 100 volt. Okay. Now, this is your simplified diagram. Okay. Now, in this loop we are going to apply the KVL. Okay, in this loop we are going to apply the KVL. In this loop means what? Tell me. This outer loop, we are considering this outer loop as a one loop, and we will apply this loop. In this loop we are going to apply KVL to outer loop. I indicated here the loop. Okay, so outer loop, what will be this one? Tell me. Because here AB terminal your current is 0. Okay, so your 100 volt will be there, minus 10 into current is how much? I equal to 0, because there is no other sources. So current will be your 10 amps. This current is your 10 ampere. Okay, now your ISC will be how much? Tell me. This is your ISC. Okay, this is at this node. What we can write? We will add these two current, and if this one is your current, then this current will not flow from this 20 ohm resistance branch. This current, there will be no current through the 20 ohm resistance branch. Why? Tell me. Because there is a, if there is a two parallel path, like this one, so the current will only flow in that branch which has a very low impedance resistance. तो इस दोनों में, यहाँ और यहाँ में सबसे कम रेजिस्टेंस कहाँ है? इसमें. और कम का मतलब ये नहीं, कम का मतलब कुछ होता तो कुछ करंट फ्लो हो सकता था इसमें, बट देयर इज नो रेजिस्टेंस इन दिस ब्रांच, जीरो रेजिस्टेंस. सो all current will pass through this one, and there is no current in the resistive branch. So our ISC is what? Tell me. ISC will be nothing but your I plus 3.5 into I. So this will be your 4.5 into I. So ISC we have calculated is nothing but your 4.5 I. By putting the value of I, that is 10 amps, it will be your 45 ampere current. So ISC we calculated. Now therefore what we can write? ZTH, or this is also known as Z naught, that will be equal to your VOC divided by ISC, and VOC we calculated as how much? Tell me. 90, and ISC we just calculated, that is 45. So this will be nothing but your 2 ohm resistance. This will be nothing but your 2 ohm resistance. So our third step will be to find out the equivalence. Step third. What is this step third? Thevenin equivalent. Thevenin equivalence. How to find out the Thevenin equivalent? Thevenin equivalent means there will be one voltage source and there will be one series impedance like this one. Okay, so this terminal is A, this terminal is B. Okay, plus minus, and what in question, is there load is connected? No, there is no load is connected. So we will make like this one circuit, and this is your V of OC, or also known as Thevenin voltage, that is your 90 volt. Because this is a DC, so we will mark the polarity, and this is your Thevenin equivalent impedance or resistance, that is R naught, and that is we calculated 2 ohm resistance. Okay, so this is your Thevenin equivalent. We will draw like this one, dotted line. So this is your Thevenin equivalent resistance. So what we seen to in this lecture, means today's lecture, that we have calculated, we solve a numerical in which we use a dependent current source, and if the circuit contains the dependent current source, then how to find out the Thevenin equivalent or Norton equivalent? Because for the Norton equivalent also we need to find the RTH or ZTH. By the same method we need to find out. We need to first find VOC and then ISC, then we will calculate. Here we are not in this question, we we are calculating the Thevenin equivalent impedance by not the conventional method, means by short circuiting the ideal voltage source or open circuiting the ideal current source, independent and dependent we need to leave as it is. Okay. Because in this condition, if you are able to, if you sorting this 100-volt voltage source, then your current, this I will be your 0, because of this current 0. So, our current source, means dependent current source, will be eliminated, which is not a desired condition. So, for calculating the ZTH, we applied the simple ratio method, that is VTH by ISC. VTH we have calculated by open circuit voltage, and ISC we will short circuit this terminal AB, and then we will calculate simply your Thevenin equivalent impedances. Now, in the first, that is the second numerical. In first numerical, we have simply solved our Norton equivalent question, that is the very simple questions. Okay. And then we have seen our Norton, what is the Norton theorems? We have discussed here the Norton theorems. Norton theorems is what? There will be one current source, short circuit current source in parallel with the equivalent Norton equivalent impedance, that is your Norton theorem. So, this is the discussion for the today lecture. If you have any doubt, kindly comment in the comment section, and kindly subscribe this one stop for all this channel, so that you get the latest update. Thank you.